Let's look at one more numerical example, which explains the diversification effect. We want to invest money into a portfolio of two stocks, A and B. We have two states of the economy this time, boom and recession, and they're equally likely. So the probability of each is 50%. Stock A, 25% return in boom, negative 15% return in recession. Stock B, 10% in boom, 90% in recession. Normally, we would be also given the weights of A and B. We don't know the weights, we just know the returns and the probabilities of the possible outcomes. So what are we going to do about the weights? Let's calculate the expected return and the standard deviation for 5 different combinations of weights. In other words, for 5 different portfolios. The first portfolio is 100% invested into A and 0% into B. In other words, all of our money goes in buying A. So B is not even in the picture. The second portfolio is 70% of money invested into A and then 30% into B. The third portfolio is equal weights, 50-50. The fourth portfolio, 30% in A and 70% in B. And the fifth portfolio, 0% of money invested in A and 100% of money invested in B. Essentially, we're going to be doing a lot of repetitive calculations. They will be very similar. We will be just changing the weights throughout all the calculations. Okay, so let's start with the first, top left cell. So the first row, the first entire row is the first portfolio, in which 100% of our money is invested into A. Essentially, it means just A. And then the next rows are the other 4 portfolios. So what are we going to be doing for each row, for each portfolio? Return on the portfolio in the boom state, return on the portfolio in the recession state, expected return on the portfolio, and then portfolio variance and portfolio standard deviation. The last row is the fifth portfolio, which is 100% stock B. So that's just stock B, right? Okay, how would we fill out the top left cell in this table? Return the portfolio in the boom state. If it's just A and we're just looking at the boom state, then it's just 25%. But more generally, we would be using the weights. So in decimals, 100% is 1 and 0% is 0. So weight of stock A, 1, times the return of stock A in the boom state, 25, plus weight of stock B, 0, times return of stock B in the boom state, right? This gives 25%. The same way we can recalculate the return on the portfolio in the boom state for all remaining portfolios. And the first column is done. So notice that what stays the same is the information for the boom, right? 25 for stock A, 10 for stock B. So we see 25 and 10 in every cell in the first column. But what changes is the weights. We started with 1 and 0. Now we have 0.7, 0.3, then 0.5 and 0.5, then 0.3 and 0.7, and 0 and 1. And the portfolio returns in the boom state become, starting with the top row, 25%, 20.5%, 17.5%, 14.5%, and 10%. They're kind of going down as we are lowering the amount of stock, stock A, which has a high return, and increasing the amount of stock B, which has a low return. So overall portfolio return in the boom state goes down. The same way we can calculate the portfolio return in the recession state. If we do exactly the same calculations as we did for the boom, but only update the numbers from the table that was given to us, and pick the returns for the recession state. So for example, if you look at 30% A, 70% B, the second from the last portfolio, then to calculate the portfolio return in the recession, we take 30% weight of A, multiply by the return in stock A for stock A in the recession state, which is minus 15%. Then we add the weight of stock B in our portfolio, 0.7, multiplied by stock B return in the recession state, which is 90%. And this gives us 58.5%. Next, how would we calculate the expected return on the portfolio, the third column? The word expected always means you must use probabilities. This is what the word expected wants you to do. If you see the word expected, it means you must use probabilities somehow. We have not used them yet when we were doing portfolio return in individual states. Expected means we're doing something that combines different states into one number. So to calculate the expected return on the portfolio, we need to use the probabilities of boom and recession, which are given as 50% and 50%, two equally likely states. So we multiply the probability of the boom state of the economy by the return of the portfolio in the boom state of the economy. Then we add the probability of the recession state of the economy, 0.5, multiplied by the return of the portfolio in the recession state. And we get 5% for the first combination or portfolio of A and B. For the other portfolios, we get 18.5%, 27.5%, 36.5%, and 50%. Then the variance is similar to the expected return on the portfolio, except where we would multiply by portfolio return in that state, we now multiply by squared distance from the 5% portfolio expected return. So for the first combination with 100% invested into A and 0% of money invested into B shares, we do probability 50% of the boom state multiplied by the return of the portfolio in the boom state, 25, minus the expected portfolio return, 5%. And that difference is squared, plus the probability of the portfolio in the recession state, 50%, or 0.5, multiplied by the portfolio return in the recession state, minus 15%, minus portfolio expected return, 5. And the difference is squared. This gives us 400. The square root of that is 20. 20% average distance from the 5% expected return in either direction. For all other portfolios of A and B, we get different numbers. So for the portfolio number 2, 70% A, 30% B, the variance of the portfolio is 4 and the standard deviation is 2. 50-50 A and B, the variance is 100, the standard deviation is 10. 30% A, 70% B, the variance is 484, the standard deviation is 22. 0% A, 100% B, the variance is 1600 and the standard deviation is 40. So we have a lot of repetitive calculations here, right? Every row kind of repeats itself, and the only difference between the rows is the weights. So we kind of plug in different numbers for the two weights of A and B, otherwise the rest stays the same. Okay, let's answer a few questions. What is the expected return on just stock A? Well, just stock A is like a portfolio which includes 100% weight of A and 0% weight of B. So the expected return on A is the expected return on the portfolio with just stock A in it, 100% stock A in it. So that's 5%. What's the expected return on stock B? That's a 50% portfolio with just B in it. Expected return on the portfolio. What are the two standard deviations for A and B? First row is just A, so we have 20%. Last row is just B, we have 40%. Next question. Which of these 5 portfolios, 5 rows in this table, is the least risky portfolio? Kind of obvious, the one with the lowest standard deviation or variance, either way. So the one with 70% in A and 30% in B, the standard deviation is 2, right? This means actually something very interesting, and that's the whole reason why I decided to include this example in my slides. It means that there is stock A, you can buy just stock A, which is pretty risky. Your fluctuations will be 20% either above or below the average return you'll be earning every year. If you just buy B, it's even riskier, double the risk. Your fluctuations will be 40% above or below the average return every year. But if you mix the two, you can reduce the overall fluctuations of your portfolio returns. So it's like you mix two risky things, but you don't get something like halfway between 20 and 40. You get something way below the riskiness of each of the individual stocks, right? Are there any portfolios here that you should never be buying? Well, look at, compare the first portfolio and the fourth. They have roughly the same amount of risk, 20% standard deviation and 22%. So they're very similar in terms of how the actual returns on these portfolios will be fluctuating every year. However, on average, on the first portfolio, you'll be making 5% more money in 1 year. And on the fourth portfolio, 30% of money invested into A and 70% money into B, you'll be making a 36.5% return on average every year. So they have roughly the same amount of risk, but you cannot even compare their average growth per year. So the first portfolio should never be in your interest to buy, because portfolio number 1 and portfolio number 5 are very close in terms of the risk, but portfolio number 4 has much higher return. So there may be some portfolios which no smart investor would ever be interested in, but everything else here, like the second, the third, the fourth, and the fifth, they're kind of up to you. Because you can notice how a less risky portfolio, like the one with 2% standard deviation, has the lowest return every year. But the riskiest portfolio with 40% standard deviation has by far the best average return every year, expected return. So, it's this trade-off between risk and return. High risk, high return, low risk, low return. So portfolios 2, 3, 4, and 5 should be what you would be looking at. You will be choosing one of these 4. But the first one should never be interesting to you. You would not be a smart investor if you are even considering the portfolio number 1. So again, the conclusion is, don't buy just stock A. Your riskiness will be very high. Fluctuations, 20% standard deviation. Don't just buy stock B. It's even higher risk. But buy a combination of two risky stocks, because overall, for your portfolio of A and B, the fluctuations in the returns may be much smaller if you find a wise portfolio. So this is again the advantage of diversifying your investment. Don't put all eggs into one basket. Diversify your portfolio. What's the best way to diversify your portfolio? It's buying stocks from very different companies, or stocks and bonds and real estate. Like putting your money in very different things. Because again, just like in the previous problem we had, what's going on in this problem is, the offsetting of losses by gains elsewhere within the portfolio. You never lose money because when you would be losing money on stock A in the recession state, you're gaining a lot of money from stock B in the same recession state. And when the return is low on B in the boom state, it's pretty good in A from A returns in the same boom state. So again, we have sort of inversely related returns. Low returns are offset by high returns, right? So the returns on stocks offset each other. When the return on stock A is high, return on stock B is low, and vice versa. So let's say, here's a question. Should you buy, which portfolio is better? You're buying Google's shares and you're buying Facebook's shares, or you're buying Google's shares and you're buying Target's shares. Your answer should be the second portfolio, Google's shares and Target's shares, because these companies are in very different lines of business. They're not affected by ups and downs in the economy the same way. And so you may be able to buy shares of stock from both Google and Target stock and observe this like offsetting of the returns, which results in your overall portfolio, return fluctuations being much lower than if you just bought shares of stock from Google or just bought shares of stock from Target.